Morning students, myself Shaifa Shah from ITICA department, and we are going to continue with the lecture series of microprocessor and microcontroller. In the last sessions, we have started the topic that is related to timers of ATmega 32, and in that we have discussed about timer 0, timer 1 and timer 2 and its programming in assembly language. Now in today's session, we are going to discuss about the programming of timers in C language, right? So also in the C language, the starting of this chapter, we have discussed about how to generate a time delay using a C language. So in that particular theory, we have defined that time delay can be used made with the help of three ways. First, that is the use of for loop. Second, that is using a predefined function in C, and third, that is using in area types. So first and second method we have already seen in the that topic. Now in this topic, we are going to see how to programming a timers using a C language. Right. So let's start with the programming concept using in the C language. Now, when we talk about this programming in C language, so here is the first example which we are going to discuss, that how to write a program in C language using the timers of ATmega 32. Right? So here the statement of the program is given as write a C program to toggle all the bits of port B continuously with some delay. Right? Here it is defined as you have to generate a some delay. Delay is not defined over here. Here it is has been given that use timer 0, normal mode and no prescaler option to generate the delay. Right? The similar way, whatever we have discussed in timer 0, the same thing we are going to load here over in the C program. So first, what were the steps in the timer 0? So first we need to load the counter, that is TC and T0 register with the counter for particular some delay, right? Then we need to generate a setting a TCCR0 register, that is timer counter control register, with the help of given options, that is normal mode with no prescaling, right? So here we are loading this two values. This is TC and T0 and TCCR0, and we will monitor TOV0 flag in the TIFR register, right? So let's see how we can write this program, right? So here we need to toggle all the bits of port B, right? So here port B is included, so we need to include the input output library files of AVR. So first line, that is hash include avr slash io.h, right? Now our next, that is void to delay, which is the function which has been discussed in the below after the main function. You can also write the function above the main function, and then particular that function you can call with the help of in the main function. Right. So here it is a two-way. First, the function is called, and that particular function is written beyond the main function. Right. But when if we want to write the function itself, then we can write the function itself in the to delay function, right? And after that we can write this main function. So as you can see in the int function, right, in the main function, what we need to do is we need to toggle all the bits of port B. So the port B will be our output port. So here we have declared port B as an output port by giving the values, or by assigning the values 0xFF to DDRB. Right? That means all the 8 bits of the port B is declared as 1 in the data direction register. So that particular port B will now work as an output port. Right? Now, while 1, that is for the continuous loop. Right? And here we have taken one data, that is port B is equal to 0x55. That means first we have loaded the 55 into port B. Right? Then we are calling some delay. So void to delay function, that is the name of that particular function. So to delay and into bracket. So we have called some delay. Then after that we need to toggle that particular data. So 55 is the toggling of 0xa. So again we will pass port B is equal to 0xa. Right? This we have passed direct data. As we are knowing that what is the toggling of 55. If we don't know, and if there is any random value which is written by the user, then what we need to do is we need to make the port B is equal to negation sign for the C language, which we have discussed in the logic operations, and port B, right? So that will generate the data, the toggle data of the data which we entered in the port B. Clear? And last, that is again we are calling the function which is to delay and into bracket, right? So here we are calling the delay. Now in the after the main loop there is a delay function, right? So void to delay which has been made a function. So for the function, for the timer programming, what we need to do is we need to load TCNT register and TCCRO register. So first here we have load TCNT0 with 0x20. Right? Here it has been taken a random value as the delay of how many seconds is not mentioned over here. Right? You can take any random value if any delay is not mentioned. So 0x20, so 20 is loaded with the TCNT0. Then here we have suggest that it is working with the normal mode and no prescaling. So normal mode, that means D3 and D6 bit of TCCR0 will be 0. So from D3 to D7 all the bits will 0, and as it is a with no preload scalar option, with the prescaler option, that is 1. So we are representing last 3 bits, that is 001. So in the TCCR0 we are loading the value 0x01. Right? Now we are checking the value that if TOV0 flag in TIFR register is either 1 or not. So here with the help of while loop, that is while TIFR end 0x01, that means the TOV0 flag is at the 0th bit. So that particular 0th bit is ended with 1, right? So what is the significance of AND operation? So if it is ended with 1, then particular original value which is in that particular bit, that remains the same. If it is 0, then 0 and 1, that will be 0. And if it is 1, so 1 and 1 will be 1. So if we want that particular value same as the original value, then we need to end with that particular bit as a 1. So here we have taken the TIFR register in which TOV0 flag is there, and we are ending this value with 0x01. Here, so and we are checking that if it is 0 or not, right? If it is 0, right, then what we need to do is we need to move out of this. We need to move checking this continuously. But if it is 1, then this while loop will get false and will load and will generate, and next loop will be indicated. So as it is 1, what we need to do is we need to stop the counter. So in TCCR0 we are again loading the value 0x00, and again we are giving the TIFR register, that is 0x01. That means we are clearing the TOV0 flag for the next cycle, right? So this is how you can write the program for the timers using the C language, right? Now let's see the another example. So here in the example 2, it has been shown that write a C program to toggle only port B 4th bit. EB 4 bit we need to toggle every 70 microseconds. So here we have given the delay of 70 microseconds. Use timer 0, normal mode, and 1:8 prescaler option to create the delay, right? And XTL is equal to 8 megahertz. So first of all, XTL is equal to 8 megahertz. So 8 divided by 8, so our frequency will be 1 megahertz. So the time taken, that will be equal to 1 microsecond. That is 1 divided by 1 megahertz. So it will be 1 microsecond. So in the solution, you can see after using the prescaler, the timing it is 1 microsecond. Now total delay over here is 70 microseconds. So 70 microsecond divided by 1 microsecond. So total number of clocks, that will be equal to 70. And that particular 70 will be subtracted from 256, right? So the value which we obtained, that is 186, and in 186 in hexadecimal, that is 0xBA, right? So we will load TC and T0 registered with the 0xBA, or you can say 186 in decimal, right? Now we need to load TCCR0. So here TCCR0 is working with the normal mode. So from D3 to D7, all the bits will be 0. Only the last 3 bits, that is 0, 1, and 2 bit will be changed. Here the prescaler option 1:8 is taken. So 1:8 is having a option, that is 2. So it is replaced by 0, 1, 0, that is 2, right? So in TCCR0, we will load the value 0x02, right? So as you can see, right here, as you can see, the first in the main function, we need to toggle only port 4th bit, right? So here for only for a whole bit, here DDRB is equal to 0xFF, that means port B is the output port. And what we are doing, whatever bit we need to toggle, that particular bit is XOR with that particular one, right? So as you can see, the 4th bit is toggle, the fourth bit is toggled or is XOR with 1, rest all the bits is XOR with 0, right? So as you can see, port B is equal to port B XOR 0x10. That means if you replaced a fourth bit with respect to 1 and you rest all bits are 0, and you will make a hexadecimal number, so it will be 0x10. So whenever you need to toggle particular bit of the port, then you need to make a XOR operation with that particular bit with 1. Clear? So port B is equal to port B XOR 0x10. Now in the delay loop, we are loaded the TC and T0 with the 186 value, right? That is the decimal value. Then TCCR0 with 0x02. Again, we are monitoring the while TIFR and one shift left TOV0. Here you can write this way also, or you can write the previous example whatever we have written, that is TIFR and 0x01. Here, so you can write that way also. If it is 0, then it will continuously monitoring in that particular while loop. But whenever it will be 1, that means it will come out of the loop, and then we need to stop the timer. So TC and TCCR0 will be equal to 0, and again TIFR is equal to 0x01. That will be again, that is clear the TOV flag. Clear? Right? So this is example in which the particular time delay has been given, and with the help of calculations which we are doing in assembly language, same calculations can be done in the C language, and then particular that number is loaded in TC and T0 and TCCR0. Right? Now next, third example, that is has been given as again port B4 continuously every 2 milliseconds. Here we need to use timer 1, normal mode and no prescaler option. So first of all, timer 1 is a 16-bit, right? So here again the calculation is given as XTL is equal to 8 megahertz, no prescaler option is given, right? So T is equal to 1 divided by 8, that is 0.125 microseconds. Your total delay is 2 milliseconds. So 2 milliseconds divided by 0.125, that is 16,000 clocks. And when you convert the 16,000 into hexadecimal, it will give us 0x, which represents hexadecimal number 3E80 clocks, right? And we need to subtract this 3E80 clocks from 6 this 16,000 clocks from this 65536, and whatever the number we will get, and we will convert into hexadecimal. So after converting this, we will get the daily value C180. So 80 will be stored in TCNT1L and C1 will be stored in TCNT1H, right? So as you can see here in void delay function, right? So void delay function, right? Main function is same as the previous example. Now, in void delay function, we have loaded TCNT1H with C1 and TCNT1L with 80. Then TCCR1, as it is a normal mode, so TCCR1 will always be 0. So it is a 0x00, and with no prescaler option, so TCCR1 will, that is 0x0. Clear? Then again we are monitoring the TOV1 flag of a particular TIFR, and whenever it will be till it will be 0, it will be monitored, and whenever it will be 1, it will come off the loop, and what it will do, it will stop the counter. So in TCCR1B we are loaded with again value 0, right? And we are making TOV1 flag again 0. So TIFR is equal to 0x01 shift left operation and TOV1, right? So this is how we can write the program for the timer 1, where we need to load and where we need to load TCNT1L and TCNT1H with respect to this. Yeah. Now next, that is example number 4, which states that again here we have to write the C program of PB4 port B5 continuously every second. So 1 second delay has been given to us. We need to use timer 1, normal mode, and 1:256 prescaler to create the delay, right? And XTL is equal to 8 megahertz. So here we have calculated, so based on calculation, as it is 8 megahertz, so 8 megahertz divided by 256. So it will give us, total time will give us 32 microseconds. And it is toggling every 1 second, the 1 divided by 32 microseconds, so 31,250 clocks, right? That is subtracted from 65536 number, and whatever we will get the result after subtraction, that is converted into hexadecimal. So the value it is 85EE, right? So again, same as the program which we have written in the last example, again the TCNT1H will be loaded with 85 and TCNT1L will be loaded with EE, right? Then TCCR1A, that is 00 again, as it is a normal mode, and TCCR1B, that is 1 is to 256 prescaler. So 1 is to 256 comes at the 100, that is fourth position. So we are loading TCCR1B with 0x04, right? And we are monitoring TOV1 flag, and whenever it will be 0 or 1, at that particular time we need to stop the counter. So TCCR1B is equal to 0 and TIFR is equal to, again we are setting the 0 for the next, right? So this is how you can write the C program for the timers given based on the pre-scaling option and the mode given to us. Right now, for the pre-scaler option and the for the mode given to us, see the previous session which we have discussed based on the timers, on which you can discuss about the how you can load the control register, that is timer TCCR register, and how you can calculate the value for the TC and TC. If you don't know from this session, right? Right. So that's all for today's session, right? Here we have discussed about the how to program the timers in C language, right? And here we are completing the topic, that is timers of ATmega 32. And in the next session, we are going to start with the interrupts for ATmega 32, right? So that's all for today's session. We will meet in the next session. Thank you for